Right, picking up where we left off. This is going to involve a little bit of hard work, because I think I'm going to take equation 1 and I'm going to say that 3 over 2 x, I have to work that out, don't I? That there, you can do it on a calculator. 3 halves take away 1. It doesn't matter how you do it, but you've got to find what it equals. Whoa, that was not right. And what it equals is a half. And of course that now equals 3 lambda. If I move 3 lambda to the other side. Oh, how about I slow it down a bit? How about I write exactly what we've got there? Minus 3 lambda equals 0. That's what we're doing. So now I'm going to move this to the other side. Then I'm going to divide everything by 3, and I'm going to get half x to the half x equals lambda. So now I've got a little expression here for what lambda is equal to. So I'm probably going to go and put that into the other equation where I need to make sure I've written the ones in front. So I'm going to go and put that into equation 2, I think. So putting 1 into 2, I've got x to the 3 over 2i minus 4 lambda equals 0. So the first thing I'm going to do is move that to the other side so that x1 to the 3 over 2 equals 4 lambda. And then I'm going to put that in there and say x to the 3 over 2 equals 4 times by, and here's everything that lambda is equal to. Wow, I definitely keep forgetting to call that number 1. Right, so this needs some tidying up. I can times those two together, multiply them together very nicely. That's good. 2x to the half x2. So now I need to tidy up, and I think my best bet is going to be to take this over to the other side, and it'll be divided. So it'll be x1 3 over 2 divided by x1 to the half, and that will equal 2x2. Obviously this looks horrible, but there's a simple rule when you divide powers where the powers subtract. And again, on your calculator, however you want to do that, you get a 1. And that 1 is unnecessary because it just means it's on its own. So now we've got a nice expression for x1, and I can finally take the result of this and put it all into equation 3. So equation 3 was basically the rearranged constraint. So 100 minus 3x1 minus 4x2 equals 0. And I'm going to put this here instead of x1. So 100 minus 3 times by the value of x1 equals 0. So 100 minus 6x squared minus 4x squared, not x squared, x2, sorry. So that's 100 minus 10 lots of x2 equals 0. Moving that to the other side, we get 100 equals 10x2. Dividing both sides by 10, we get 10 equals x2, or more pleasantly, x2 equals 10. And that's our first solution. And then the next one, we already know that x1 equals twice x2, so x1 is 20. And now we just need to put it back into the very, very, very original constraint here to make sure that 3x1 plus 4x2 equals 100. So 3x1 is 60 plus 4x2 is 40, and yes, that equals 100. So this is looking very good. And we can now find that lambda is, wow, okay, lambda is half x1 to the half x2. Lambda is a half x1 to the half x2, which is a half times by x1, which is 20, to the half times by 10. And you have to type that in a calculator because I don't know what it is. Let me see if I can see it written down somewhere. Not yet. So I'm going to type it in now. I don't know if I'm right or not. This is all my first guess, but I think it's going to be something messy. So I think I'm going to stop there and finish it off in a bit.